Yeah, okay, we're live. Good.
Have you eaten like dinner?
Yeah.
Because
Have
I'll need
you?
to eat dinner in an hour.
Okay,
So
that's fine. That's fine. We'll work around that. Let me get up
scrub,
MS.
scrub, scrub till they're
Let me
dirty and
get up
brown.
the ultimate.
It's so deep.
Maybe some people will listen in. Maybe some people won't listen in. You know. Paint. Where's MS Paint? Where have I put it? Scrub, scrub, scrub till the water's brown. Okay. Screen share. Share. Present to everybody. Okay, I believe that should. Oh my. Jesus Christ. Let me see.
Yeah, hold on. I'm just opening the window. Hello.
I think my screen should be sharing.
Yeah, it is.
What you can see, paint.
Yep.
Excellent.
Write something.
Huh? Write
Right.
something. There's a bit of a delay.
Well,
Keep that
now
in
it's
mind.
gone.
Okay, no, it should be back. Yeah.
What?
Are you watching the stream?
Yeah, no, I can't see anything.
How about you can't see anything?
No.
Oh yeah, Ben's watching. Okay, good, good, good. Here, you should be able to see now.
Yeah.
You see it?
Mm-hmm.
Fine, then I assume Ben sees it. Should we start?
Yeah.
Okay, let me. Do you have your textbook with you?
Sort of.
What
I
do you mean?
have my revision guide.
Yeah, your revision guide. Just everybody get their revision guide. What do you mean you've seen nothing, Ben? Nimrod, do you? Oh, Ben, you should see it now. What is wrong with this? You've seen Nimrod's icon. How about? I think you should see it now.
What?
Oh, there. Do you see it, Ben? Well, okay, we're going to start, Nimrod. Nimrod, get off of Facebook.
Mm-hmm. But I'm doing important things.
Come on, we're meant to do this legit.
Uh-huh.
So, do you want to start from the start? And just go through it?
Okay, how many people are watching though?
There's 2 people.
So that means just one person.
Why are you watching it?
Yeah. How do I not watch it?
I don't know, just click off of it. It doesn't matter, let's just do it to revise, and if more people join, so be it.
Mm-hmm.
Okay. So we'll start from the start. That's probably a good way to do it. So start with functions of an operating system, I guess.
Yeah, bro.
So
So
An operating system must do the following things.
Communicate
to
communication
provide.
between hardware and software.
Are you reading from the white textbook?
No, but it's just my knowledge, bro.
That's good. The textbook says it provides and manages hardware resources such as memory management and jobs passing through it. It provides an interface between the user and the machine.
No, you need to go more slowly.
How slowly? We have like 50 pages to get through.
Yeah, exactly. By this, we're on good
In fact,
schedule.
are we just wasting our time doing these? Is there some like specific chapters we should do instead?
Yeah, ask the crowd, ask the audience.
Go on, Ben. Post something. I know what he's going to post.
How do I get up the chat?
I have no idea how this software works.
There. See. How do I see how many people?
I can see. I think we should. There's a bit of lag,
unknowns.
Huh?
Okay, what? Yeah.
Should we do some binary?
Nah, that's easy.
Yeah, but remember the exponent and mantissa thing. Oh,
yeah, but that's 2 marks, and I got it. But okay, if you want to, you sure.
Jamie, just.
Are people writing in the chat?
Huh?
Are people writing in the chat?
I don't know. I'm not watching the stream.
Oh, okay, fine. So.
Ben, if you're watching, just
Seen by everyone, and there's not here. That's a bit rude.
No, Ben. Should I have Ben?
No. No.
Should I? No. What do you mean no?
No. Oh my.
Too many people want to join.
Who wants to join? Where are you seeing this?
On Facebook. Okay, what should we do? We should start.
Okay, it's memory management and scheduling.
Okay, let's turn to these pages.
Mm-hmm.
What page is memory management on?
Oh, well, let's just recap it.
Okay, so you know the bullet points. So why is memory management needed?
To maximize the use of memory. To allow. Okay, I'll turn that on. So,
Yeah,
to maximize the use of memory, of the primary memory, to allow tasks larger than the memory available to be processed, to protect data from software, to protect the data being used by software from other software or tasks, and also to allow data to be shared between tasks, and also segmentation / paging / virtual memory.
Yeah, and yeah, they protect jobs from each other. If something's in one memory location, it stops it being written over or clashing in memory locations. Yes, I like that.
My mom literally sent me a picture of a pen.
Uh-huh.
Oh no, wait.
Should we do some UMLs?
Yeah, sure, if you want.
Yeah. I know Ben would like
everyone.
Everybody likes UML.
The thing, I have trouble with the names of things. Not actually.
Okay, let's go through them. Because I can draw them out on my screen. So the first one we have.
Then maybe FDE cycle.
Yeah, maybe fetch, execute.
Fetch, decode, and execute.
Okay.
Class diagram.
So what should we do first?
Class diagram.
Class diagrams.
Yeah, class diagram.
Okay, fine. Yes, class diagram.
Okay, first let's define UML actually.
Go on, you can do it while I try and draw it out.
UML, Unified Modeling Language. Listen to that. Is an unambiguous way of explaining how an algorithm will work, right? And if they ask you in a question, you need to talk about system analysts, programmers, and clients all being able to understand the same thing, even though they've got different backgrounds and knowledge and stuff like that. So that's a good thing to know.
Yes. Yeah. So this is kind of like the basic section of a class diagram. So this is one of the classes, and an instance of this class is called an object. So it has the class name, it has attributes, and it has methods associated with it.
Methods are functions, attributes are variables, and the name is the name.
And yeah, and also this class can inherit attributes and methods from a superclass. If I can try and draw this out, so it can inherit properties from that superclass. What else is there to it?
We'll talk about what derived classes.
Oh yeah, so this is a derived class of this class because it's able to inherit the attributes and methods from it. Derived classes are always really on lower levels than the superclass. They're also called
like a family
subclasses.
tree.
Huh?
Family tree.
Yeah, like a family tree.
But encapsulation. That's a encapsulation. Data encapsulation, Alex.
Oh, data encapsulation. So that's where.
Wait. Yeah, you carry on. Hold on. I need to do something.
So that's where the attributes inside a class are only available by the methods. Only available by the methods inside the class. So they can't really be accessed in any other way except from the methods here. So these attributes, let me make this brush thicker. These attributes can only be accessed by the methods in the same class. They can't be accessed by methods in other classes. So it's really a one-way. So you can only relate or good.
What have you been explaining?
Yeah, I have been explaining.
What have you been explaining?
Data encapsulation.
What have you said about it?
So it's where data or attributes can only be accessed by methods within the same class, really.
Yeah.
That's pretty.
You also need to know why you would use this.
I don't actually know why you'd use it.
It's about data integrity and security to make sure that the only way to change or access data is from predetermined methods.
Yes.
So you can't say age equals -64 accidentally. You need to do it through methods.
Good. So that's pretty much a class diagram, isn't it? There's not much to it apart from that. The next diagram is an object diagram, and these can get a bit. Actually, no, these are very simple, aren't they? So an object is an instance of a class. Let me try and draw it out. So
another way of writing it, an object is a real-world entity.
A real-world entity.
An object is a real-world entity that has been created from a template called the class.
Yes. So normally object diagrams are kind of they use something called an anonymous object that can represent all the objects of a class. So an example would be, how do you spell vehicle? Yeah, like that. So that would be an anonymous object.
LE.
LE, good. 1 second. I'm getting a call from somewhere.
So an object diagram
Huh?
Nothing. That's just nothing.
Yeah, no, go on. Elaborate.
An object diagram is basically.
Let me get Ben.
It shows. What does it show? it represents an instance of a class. That can
Yeah.
be,
So this represents an instance of the class. Give me a second. Let me just add Ben because he wants to say something. It shouldn't get too messy. I'll only invite Ben and then there. Yeah. So this is an anonymous object, and normally to make the class become a real life entity in an object diagram, we do this. So we have the name of the object. So in this case, a car is the name of the object. Hello? Good.
Oh, you're right.
Yeah.
Okay.
And then we have the attributes, but we assign those attributes values. So number of wheels in the text because 4, and you just assign them attributes. So instead of being kind of a generic template for an object, you give proper values to them.
mm-hmm.
What else is there to object diagrams?
Mm-hmm.
I think they still have the methods in them as well.
Yeah.
No,
well,
not in the textbook. That's class diagrams.
not in
and
the
methods.
Well, they don't need methods because the methods are going to be the same.
Yeah.
Oh, I'll use specific instance, yeah.
Yeah. So that's object diagrams covered. There's not much to them really. They're just bringing a template to life. Should we do use case?
Oh,
That would be the logical step forward, isn't it?
Huh?
That would be the logical step forward. It wouldn't, because use case diagrams are stupid.
Do you want to explain it while I draw it out?
Sort of.
You can
I'll
try if you want.
A use case diagram. Let's be legit. You'll never need to know how to use it, but it basically just shows how, because it's so simple. Like, it doesn't even make sense. Like, why would you write it like teacher student teaches, or no, teacher teaches student?
Yes. So it's just
Human
that in the
uses
exam.
car.
In the exam, I've seen the question. So it's like identify the parts of this. So if this is the student, this is the teacher. The initiating actor would be the teacher because they are initiating the teaching. And the receiving actor, which is this stick man, is the student because they receive the teaching. The lines I think are called association lines, and this is called the use case. This is the actual use case. This thing. Yeah. What else? These are called actors, association lines, use case. That's all they could possibly want. Anything else, guys?
No, it's that simple. There's only been one question in past papers, and it's state what they.
What year was that?
2014. It was the last paper we did. Well, I did.
Okay, so maybe it may come up if it's very simple. If it does, the next one is communication diagrams, which
9 marker on a use case diagram.
That's not dreaming, Rod.
120 markers.
So
on use case.
These ones I don't like, communication diagrams.
They're simple. They're simple, but what tricks you out is how simple they are.
Okay, let me try and draw this out. So you have manager. So I'm guessing these are anonymous objects because they have that colon.
Yeah, they are.
So
yeah, they're classes.
Yeah. So these are purchasing, and we have accounts. So, anybody else want to do this bit, and I'll draw it out.
So basically.
Oh yeah, go on.
Hold on, I'm just writing stuff because get that into your brain. So basically, what a communication diagram is meant to demonstrate how the different parts of a system communicate with each other and what messages they send to each other, right? So in this case, we're modeling. What are we modeling? How? What's this example of?
I believe this is just requesting accounts.
Requesting account information. This is a bit complicated. They'll probably only have 3 boxes, but
Yeah.
what they could do. So let's say in this example, you draw a one, Alec.
Yeah. Sorry, not Q.
A 1
Request
accounts. Close bracket. A.
account.
C. C.
1 second. 1 second.
O. Okay.
Jesus Christ. Yeah. That's request accounts.
Cool.
So this is a method, isn't it?
Yeah.
That's a method. What else is there in a? It's only methods, isn't it? What else is there?
There are conditions.
There are conditions. Yeah, they don't put this in the text, but aren't they in square brackets?
Delete everything. Delete everything.
Yeah.
Okay.
Yeah.
Okay, and do 3 boxes. The top one in the triangle. In the triangle.
Fine. Yeah.
No. The top. A triangle of 3 boxes.
Oh. So.
Okay, right. So the first one be human. The second one be garage door, and the third one be. And the third one be keypad.
Human. Garage door.
Mhm.
And keypad. Yeah.
Okay. So the human. Draw an arrow from human to keypad.
It's. How do I do this in this?
Just use a line. It doesn't really.
Yeah. Fine. Yeah. A human to keypad. Yeah.
Right. So that next to that will be the number 1.
Yeah.
Followed by the function press button B in brackets.
Button. You mean B as the parameter?
Yeah.
Yeah.
Okay. Yes. Okay. Now, under keypad, there'll be like a sort of recursive arrow. So going out of keypad and into keypad. And the text next to it in square brackets.
Yeah.
If but B equals up, B equals.
Yeah.
In square brackets.
Yeah, I thought so. Square brackets.
Oh, I did say that, so
Yeah.
just don't get their face now. Square brackets. Oh no, if B equals up, that's all.
If B is up.
Yeah. Right. So then another arrow from keypad to garage door. Right, and there's a condition next to that. If garage door does not equal up, completely up, or like.
So if it's a condition, so if garage door
does not equal fully contracted.
I'll just say up.
Yeah.
Yeah.
So then like the exclamation mark.
Yeah, not equal. Yeah. So does it actually?
And then next to that, and then the action you do, move garage door moves up, right?
How do you draw an action? It's
just like the function from keypad to move garage door up. To
move.
No. Oh no. Yeah. What are you doing? No, it's a function.
Yeah.
So you move garage door brackets up. No, the up.
Oh, the up in the.
Yeah. Alec, you can't use a computer.
Like that.
Yeah, but there's a 2 next to it. And it's 1 word.
Oh yeah, sorry. To move garage door up.
Yeah.
So
And
this
then I
is
don't know.
what's this called?
That's another function.
Yeah, it's another function.
And then I guess from garage door to human, it would be garage door moves up.
Yeah.
But
Which diagram are we doing?
Oh, it's one of Nimrod's.
this is a communication diagram. I just made it up on the spot. That's why there's nothing linking garage door to human.
Yeah.
Communication diagrams, according to OCR and to this, don't have conditions. It's the activity diagram that has words in the square bracket. If you have either of you found the OCR material for UML?
I've never seen an activity. Look, I'll show you the past paper that I did with this.
I've seen square bracket conditions in this.
Like there was a 6 marker and 3 marks.
Yeah, there was.
Which paper was it? Because I've never seen that before.
I'll show you. Alex, can you show this on the screen? I'm just going to send it to you via FB.
Yeah, I can try to. Actually,
No.
I can. What am I talking about?
Don't
Yeah, here you go.
Like this was a real mark scheme. Believe it or not.
What the? Right, okay.
This was the worst paper ever.
What did you get in it, Alex?
I can't remember.
Like, see, like that's
Oh God, that's stupid. Because they even in their own material that they had to make because they didn't have anything.
But look what you get the marks for. You get the marks for just having numbers.
Yeah, because it needs to be a numbered sequence and then 2 or more. So was the question just to draw the communication diagram?
yeah, no, it gave you a description of when he presses the keypad to switch it on. Just it beeps and then it switches on.
Right. Okay.
And all it had was the 3. It had the 3 classes, but that was it.
Yeah. It was a particularly nasty one.
Okay.
So you can see, yeah, these are obviously the functions and what this is a condition.
Yep.
Yeah.
And then these are the anonymous objects, and these are. Do they give the arrows a name? No, just direction in which information flows.
Yeah.
Yeah. Okay. Fine. So that's pretty much communication diagrams done.
Mhm.
Do we need to do state diagrams?
I think they're pretty simple. I don't even think you have to draw them in a.
I have never seen a question worth more than 3 marks about it. I've seen entry point, exit point, and state diagram. That's all you needed to write.
Yeah.
Obviously, they're going to give us a question.
And also triggers, the triggers that change the state of the system.
Yeah. You need to remember triggers.
Yeah.
But no, I don't. I don't think. I mean the actual. Yeah. No. Okay. Fine. We can skip over that. Should we do sequence diagrams?
Yeah, I think they're a bit. They're not too difficult actually. They just look more complicated than they are.
Let me see if I can get a picture up of a sequence diagram because I'm not.
Oh my!
drawing
Imagine
that.
an A mark on local variables, global variables, and parameters.
I did that today.
How big would that be?
I did it in today.
How big would that be?
Yes, but unfortunately, ain't gay. Here's a nice sequence diagram.
Look at question 11 of this. This is.
Send me pictures if you.
I can't really.
Okay, fine. Let me. Question 11, you say? Let's have a look. Ooh, this looks interesting.
Like that's the most they've done on UML.
Okay, there's the actual question. Do you remember the actual question? Let me check. So the first question, we can just do it together. Give the correct name for each type of UML diagram. They've only
Right.
given. Oh no! Wait.
Each figure, I'm guessing, like each diagram.
Figure 1 is a class diagram.
Wait,
Figure two
wait,
is a-
Nimmer, don't spoil. Don't spoil.
But
There we are.
is this a whole question?
Yeah.
Wow.
Oh wait, I got it all in the first time. Yeah. So what? Figure 1's class.
Figure 2's object.
Yeah, and figure 3 is a sequence.
What are the dotted lines called, Alex?
Lifelines.
What do they represent?
I hate this. The time an anonymous object is in the system for.
Yeah, or if you want to be fancy with words, the duration the object is active.
Please jump off a cliff.
Why?
I'm joking.
Why?
The following questions, let's do them. Wait, let me just get the screenshot. So, here we are. Ben, do you want to do the first one?
Just showed in figure 1. Inheritance, is that one of them?
What, state the feature of object that is shown? Yeah, I guess so.
Well, because
Yeah, inheritance.
Yeah, it's inheritance.
Okay.
State your information from figures 1. So an object. Who wants to do that?
What's
I
an
don't know.
object?
What?
What's an object?
What do you mean, what's an object?
Figure 2, that's the answer.
Surely the object is alarm.
No, it's my alarm.
My alarm's an anonymous object.
No, alarm is the anonymous object. My alarm is...
Oh yeah, sorry.
Object.
Yeah, I read it the wrong way around.
Well,
My alarm. Sorry.
You missed out a whole mark on that one.
I saw the colon.
120th.
A class is like, it's going to be pressure sensor, motion sensor, sensor. And a message would be, is something in figure
You
3.
missed out 0.83% of the paper.
0.83.
Yeah.
A message would be,
No.
light?
Light on?
Light.
I don't know whether it's B, because the method process message has a parameter B. So surely
Yeah.
the message is B.
Maybe.
Have you got
Yeah, I mean, in
marks?
the textbook it says here, light is an output.
Oh yeah, I can see that actually.
And methods are obviously the ones with the functions. And yeah, so I guess the parameter would be the method.
Have you got the marks?
Message.
Sure. June 2011, let me check. 2011.
In the revision guide, it says nothing about the... Oh. It says nothing about the message...
No, they don't, but by deduction.
Again, in the revision guide, though, there's nothing about SQL, so...
It's
Yeah,
a
it's true.
pretty great textbook overall.
Well,
11. Superb, I can't find it. I'm pretty sure we're right though.
Was it June 2011?
June 2010.
Okay.
Oh my god. In
Oh, I found
the
it.
new course- In the new course, I open it up. It's like MAC addresses.
GG.
Here, it was an example of a message was get button press. So they're the functions.
Yeah.
The methods are supposedly the messages.
The methods are the messages. Great.
Why can't they just use one term?
Because it's OCR. They're ambiguous.
Yeah.
Alex, I opened this up. I opened the book up and look.
You looked.
Can you see that?
No, because I can't see anything. Oh yeah.
How to talk to cat.
What book is that?
It's the OCR Computer Science for A level. The one that doesn't have our course in it.
Very nice. So we've done sequence diagrams. We get that.
Yeah.
So wait, just to go over these blocks that I highlighted. Oops, I can't highlight them. But so that's when the object is actually active in the system, I think.
Yeah.
Yes.
Yeah. So that's okay. Excellent. Do we need to do activity diagrams?
No. I mean, it's.
Nimrod,
fairly
I guess you don't want to as well.
I've never seen one in my life.
Okay, fine. We can.
And they're flowcharts. It's like
They're pretty much flowcharts.
Yeah. Effectively.
Are we all sure we don't want to do any binary?
yes.
I'm
I'd rather do SQL. Probably. Okay. What I know is you create. Right.
Yeah.
There's what's it called? Hold on.
Here, wait.
What is
You don't need to know SQL,
You do.
do you?
It could ask you to write a basic SQL statement.
Oh, fine. I guess it would only ask you to select, so you'd have like.
Yeah, it asks you to create select, and also to select
Yes.
from table where something equals something.
So you have select. Let's say star. I don't know.
No, not star. Select names.
Yeah. No, it could be star.
Yeah, but like I don't want to select star from table.
Okay, fine. So what should we say? Select
No,
name.
no. Select name user ID.
Fine. Select user ID. And let me highlight that in red.
Wow.
User ID. I know, how legit does that? Oh no, I can't edit the. Kill me.
Oh my god, Alex, do you need me to do this?
Select user. Oh my god. Select user ID from table name. Daniel, you're not coming in the call unless we need specific assistance.
Wait, is he watching?
I believe so.
Oh my god.
Yeah, Caudal, fine. Give it a bit. Let us just get into it, and then you can join. So select user ID from table name,
Where?
and then let's say,
First name.
yeah, first name equals Dan. It's like that. So that's a select,
Mm-hmm.
and then you have the create query. Create.
Create giraffe.
What are we gonna?
Create table giraffe.
Yeah, create table. I can't spell. I give up.
Not all caps though. Giraffe.
Yeah, unless you want it to be caps.
Yeah, but you don't because reserve.
Yeah, you shouldn't. Yeah. And then you're going to you want to normally have your fields in brackets like this. So you're gonna have.
Oh my
Can
god,
I-
Alex. Do you know? Oh god.
Oh my god. Column name. And then I don't know the size of it. No, the data type then size of it, isn't it? So int 100, and then you continue on like that.
And also remember primary key.
And what is it? It goes primary key. I don't know.
Giraffe ID.
Yeah, giraffe ID or something like that.
Yeah.
I don't need to write it out.
Good. You don't need to write it.
No. I mean, they're the basic. I think just select is really the vital one.
Yeah.
Maybe insert. They might ask you to insert data into an existing table.
So what you have insert into table name.
Yeah.
Table name. You can have a where here, can't you? So where, I don't know, first name equals Alex, values, and then you stick in your values here. So let me just get one from the internet because they'll probably have examples.
Well, just go on to W3 schools. They've just got examples there.
Insert into here. Here, this is what these cheeky buggers have done. Like that. Insert into.
Give me a sec.
Go on. So it's like that.
Yeah.
Yeah, and that's how you insert into a table. There's also well, I'll wait for Nimrod to get back, but there's a good way to remember DML. Has John told you that the CRUD?
He didn't, because I just sort of get it. Like the database management system, it's got the data definition language and the data manipulation language. So data definition language.
No, just talking about DML.
I need to go quickly do something downstairs. I'll be back in.
You mean eat?
No. I need to just switch on my hot water for pasta.
Fine, cool.
Save the DML DDL.
Fine. We'll
2
save
minutes.
it. We'll save it.
Talk about something unimportant like compilers.
Secondary key.
So that's just another possible primary. So if there are two attributes.
Yes. The thing is, I know what you're going to say, but that's not actually what they put on the mark scheme.
What do they put on the mark?
So they actually put. It's true that it's another field that they can use as a primary key, but what they said in the mark scheme is it's a field that you can index for faster searching of data.
That is scrubby.
So you index it. So the more fields you index, really, the faster the searching.
Okay. Also, John was saying today that a primary key, like it doesn't have to be just one field.
No, you can have multiple primary keys.
Yeah.
Talk to me about views of data.
Okay, so views is basically, so if you've got a relational database, it's got different tables. Views allows for like a certain portion of the data to be represented in a virtual table. So you could use a query, like select from wherever. So they're pre-existing queries that you can use to produce a virtual table. So it's useful for security because it can ensure, for example, say if in a database for, I don't know, like an online shop, so somebody needs to check stock levels, it ensures that they can't say, have a look at the customer information, which they don't need to see.
Yeah.
So it can either be done by, like, you can use passwords or just checking whether that computer is allowed access to that particular.
Yeah, they're just basically filters.
Yeah.
That's what I like to think they're.
High complexity. Yeah, so it's just basically, it's a dynamic virtual table, so it's not like a fixed table from the relational database. Yeah. Obviously, a flat file can't have a view because the whole table is.
You can only access or not access it.
We should probably wait for Nimrod for the 3 normal forms, although I fairly.
The 3 normal forms? No, I think Nimrod. Oh, I love addressing.
Addressing is the question in June 2014.
Yeah, I know all about addressing.
I love addressing.
It was snaky. The mark scheme for June 2014, there was the question. Do you remember, Alex, when it had 3? It was like the person had lost their notes, and it was the question.
Oh, I did that one.
Nimrod did this.
Yeah.
Get the question up so we can dissect it.
Yeah, go on, Alex.
Oh, Jesus, what paper was it?
2014.
June 2014.
Yeah.
June 2014, F453.
I want to see if there's anything in the 2015 paper.
Do you remember what question it was? Oh, I think I did this. Did I? No.
You've done that paper?
Yeah, I know. I thought today. What question was it?
A later question. I can't remember exactly.
That's a very nice band. Very good.
Indeed.
Okay. Oh, was it the What a blissful. Was it the tick the box one?
While you're searching that, DML DML, create, update, read, and delete.
Update. Yeah, CRUD.
Yeah.
Yeah.
I love
DML
CRUD.
CRUD.
Yeah.
DDL, a bit more complicated. Writing schema.
DDL writing schema. Are you sure they write schema?
I think so. Rules about data.
They're rules about data. Schema's a completely different thing, I think.
Okay, rules about data, like not null, whatever. Type of data type.
Validation.
Like,
Yeah.
validation. Table architecture or relationships.
Yeah. That's mainly it. It just says here structured data types validation.
And I believe isn't it stored in a data dictionary?
Yeah, it is.
Yeah, stored in DBMS, right?
Yeah, it's stored. Well, yeah, a data dictionary.
And can we just DBMS? Can we just cover that as well?
Well, DBMS. I did a question on it today. It just consists of DDL and DML. I don't know what else you can say about it. It's not its own thing, is it?
No, it's the sort of umbrella of those
Yeah.
two languages.
It's like
But what are the main features? Because I've seen one of the a question like a 4-marker main features of a DBMS.
Let me see. I did a question.
Well, I guess you talk about the data definition language and data manipulation language and what they can do.
Yeah, there's.
Data dictionary as well, right?
Yeah. That stores, yeah.
Yeah, I did a question on it today. It
Does
said
also,
describe a DBM.
provides views of data, right? And can produce reports.
Yes, Jason, it is going well. DBMS.
I don't know. Nimrod was right, Alex. The design of the databases and relationships within the database are called the schema.
But is that done by the DDL?
Well, it's within the database management system.
Yeah, it says here at the bottom, the design of the tables and relationships within the database is called a schema. It's not necessarily done by the DDL.
But it is.
It doesn't say it here.
I did a past paper. I'm pretty sure it is. We'll
Jason-
write it in.
Jason, if you're watching this stream, just Facebook message me. Is a schema part of a DDL, or is it? The schema, I believe, is just a file containing everything
but-
about the database.
Yeah, but I'm pretty sure you
the
use
schema.
DDL to write schema.
Let's see. Is Jason watching? Let's have a
Just
look.
ask him. Do like phone a friend. Ask for Jason.
That Caudle just said he isn't. So Caudle, post your opinion. Oops, Caudle.
Yes, it is. I've just searched. It says a data definition language is a computer language used to create.
Yeah, no, Jason just messaged me saying the schema is just the design of the database.
Yes, but it can be written in DDL.
Yes, Alex. Trust me. Relax.
And if you write it in there, you're not going to get marked down. Just write it in with something else if you're not sure. That's basically what happens every time you get to a question. You just throw up as much stuff as you know and hope some of it's right.
Okay, sounds like a plan. Caudle wants to cover reverse Polish at some time, so we will.
Oh, that's swag. That's good.
What were we going to go on to?
What's on the screen?
Oh yeah.
Okay, so this is quite a nice question, I would say, an easy.
Well, let's analyze.
The 11 marks. Okay. So the first one is because the low-level language is very close to design of a processor. You can also You can also manage individual bits of memory to make it more efficient because a processor has less storage, and it also what's another point?
A washing machine doesn't require as many complex operations.
That's the right one. Yeah.
Yeah.
Not many complex.
Let's do B because that's mainly about
Okay.
addressing.
Oh, that's a
So
good.
let's each take a row.
Immediate.
Okay. Yeah, I agree.
It's direct.
No, it's direct.
Oh yeah, it's direct. Sorry, it's the wrong way.
Add is the operand. Ben.
That's. Oh, none of these.
Yeah, it's none
That's
of
such a
these.
snaky question.
It's a stupid one. The date that's immediate.
Yeah.
And mean dog.
None.
The address 123 are the value which. The
None.
address.
That's indirect.
Yeah. Oh yeah, they didn't put it here.
Yeah.
Okay, this can be either indexed or relative.
What the hell are you talking about? What question
See.
now?
See.
You read that quick.
No, I did it, so I know.
Let's read. Kaz is standing there.
What
Oh,
name
poor
is
Kaz. Oh my
Kaz.
god, what a sublime question. Okay. What are you going to
That's
say,
not-
Nimrod?
Okay, so it can either be indexed or relative.
Yes.
Indexed
Why
addressing.
don't you want to do indirect?
because that's
Oh
not
yeah,
correct.
yeah, sorry.
So indexed, what's basically done is the addresses are added to a base index value, 3 in this case, to achieve the new value.
Yeah.
Right? That's what you need. You just need the example.
Yeah.
So the base value is 3 and the current value is 11, so then you get the address of 14.
Mm-hmm.
Relative is when the address used is relative to a starting point. So in this case, the address you used, the starting point is 3, and the address being accessed is 11 addresses past 3.
Yeah, and I believe that's useful for searching arrays and stuff.
Arrays / branching.
Yes, array/branching.
That's direct quote from Mark's game.
Caudle was very active in his Facebook chat. Caudle, calm down. You'll get involved. Caudle's a bit behind. He asked the difference between indexed and relative.
Oh, what a scrub.
GG.
But
What
I
can
think
indirect addressing be used for?
it's to access more memory locations, basically. Because direct addressing only has the maximum value of data locations it can access is the maximum value that the CIR can hold.
Yeah, it's the number of bits that are available.
Number of bits that are available.
So
Caudle just said, "Good job not actually answering the question."
Ask him to go back 2 minutes.
Maybe he'll catch up. Maybe he's a bit behind.
Yeah, he's in Slovakia right now.
So, yeah.
So, computing. We're done, right? We can go and get a star.
GG.
Okay, Caudle is very eager.
Tell him to look at the screen. There's text on the screen.
No, he's very eager to get involved.
Oh, but then everyone's involved and no one's watching. It's like, what the
Caudle,
point?
5 minutes and then I'll add you.
He can tag in when I go because I need to eat.
Fine, when you go to eat. Do you want to?
Here's a challenge for you. Write an algorithm that shows the merging of 2 files.
Oh, I've seen that.
Oh, that's a
Saying
good
that's how I know how to do it. Let's be honest though.
Caudle says our index definition and our relative. Caudle and.
Well, I know our relative is definitely 100%. It's pretty standard.
Yeah, and our index is correct. There's I believe it's called an index register, which holds
the value of 3 in this thing. Yeah.
Yeah. Although it's right. There's nothing wrong with it.
Ecuador, if you want, you can talk to me, mate.
Yeah, talk to Nimrod. What else is there? Oh, what did you want to do, Nimrod?
I told you what?
Oh.
Merging.
No. Fine. Yeah, we
DML.
did DML.
Hold on. Let me just whip a look in this book. So, do you know about interrupts?
I'd hope so. Okay, let me think of the hardest thing that I've come across in the past paper.
Maybe the use for stacks in an interrupt.
Yeah, I did that. No, that's not particularly hard.
Yeah, but nothing's hard. You just need to know it.
Okay, do you know the entire boot process off by heart? And I mean loading sys.io kind of hard.
No, but I know the booting is to load the OS, is to load the preferences, the user preferences from the OS.
That's the boot file.
The boot file, yeah.
Yeah. Do you know the process?
I know it starts with the CPU being initialized, and that involves locating the BIOS.
What happens? What happens? I like this. You turn the computer on.
Okay, so the CPU, it clears register.
Wait, no, you're too eager. First, it needs to run post.
Yes, but post is only run once the BIOS is found.
No.
Hang on here.
The
Okay,
post.
first you press the button, right? Then the BIOS starts up.
The post.
Post
looks at the
happens
BIOS.
at some point.
Alex, I'm reading it right here. The BIOS will run its power on self-test. You have to find the BIOS.
Firstly, the computer runs the post. The post routine checks the BIOS chip.
Yeah.
Okay. If they ask us, everyone's screwed except for you.
No, you're saying it the wrong way around, Alex.
I'm literally reading out the book.
So am I. It says when the computer is first turned on, the revision guide, the CPU initializes itself.
I'm reading out the other book.
And then it says part of this initialization is to look for the BIOS. And then below it, it says the BIOS will run its power on self-test.
That's interesting, because this book says it the other way round. First the post is run, and that will look for CMOS. Okay, whatever.
Boot process.
Let's live
BIOS. Okay, when the CPU is the CPU initializes, then the BIOS. It looks for the BIOS. Some of the BIOS is stored in ROM. The BIOS will run post, checks the BIOS chip, verifies CPU registers, checks hardware devices, loads the addresses for the first instruction of the boot program. Cool, done. Do you know about spooling?
Do I know about spooling? Spooling is my love.
You hold Shift and B at the same time, right? You get it up to speed, right? And then you release B and start rolling down the runway.
Hilarious. Why the hell is B your
Brake button.
Oh yeah. I haven't played in such a long time.
Spooling, right? 3 points for spooling.
What is spooling? So it prevents speed mismatches between the CPU and the I/O device.
Mm-hmm.
I mean the printer really.
Well, just so any peripheral device. It doesn't
Any peripheral really, but mainly printers. I think they like.
It's the common example, yeah.
Yeah, because printers are slow, guys. But to be fair, there's so much racism against printers.
Okay, Nimrod.
Okay, second point.
What else is there? There's a
Allows for jobs to be shared over a network.
yes, the spool queue is held on the network.
Yeah, allows to prioritize jobs.
Yeah, you have priority in the spool queue.
A second part of the first point is that it frees the processor while
Yeah. So it can
allows for-
continue with what it has to do.
describe an interrupt.
No, you're not done yet.
No, we're not.
That was 3 marks.
I need 6.
Six.
6. I need 6 marks.
6 marks. Just say it twice.
More vitally, I've got a very interesting question here.
Interrupt first.
Interrupts a signal sent to the CPU to request processing time. They have priority, prevent data loss, yada.
Stacks as well.
Stacks, yes, stacks interrupts.
Stacks are used to hold the contents of registers while interrupts are being processed. When is an interrupt detected?
Yeah, after the fetch execute cycle.
By what? Where is it detected at?
The interrupt queue.
No. Is it?
Yep.
Yeah.
So after every FDE cycle, the interrupt queue is checked to make sure that there's no higher priority interrupts in the current job.
I've got a question here.
Mhm.
Do both compilers, when I say compilers, I mean the compiler and interpreter, I mean translators. Do they both produce intermediate code?
No.
Maybe.
Hang on.
Here we are. Because I'm pretty sure the diagram in the book is.
I know compiler produces intermediate code, which is
Yes.
then interpreted by the virtual machine.
But but I'm pretty sure a virtual machine only. I think they both do,
That's what I thought. I think they both do.
but I'm not sure. I think they're both optional.
Oh my.
They're both optional for both of them.
Yeah.
8 marker on intermediate and virtual machine.
I did that. It's blissful.
Yeah.
What else is
Is
there?
that Ben?
Hi. Oh, she can't hear me. You're wearing headphones, aren't you?
Ben, come on, get your brain into gear. Why the hell would me wearing headphones Sorry, I'm just being stupid.
Yeah.
I'm the one that doesn't have my brain in gear.
Yeah, exactly.
I thought she wouldn't be able. I thought you meant she wouldn't be. You couldn't be able to. Oh, whatever. Oh, good one. Do you know about array processors? Because these are my.
Yes.
I was just doing questions on those.
One CPU with multiple ALUs to
Yeah.
allow the same task to be done on multiple sets of data, e.g., the same thing to different pixels. In a
Yes,
graphics card.
it's called SIMD. Single instruction multiple data.
Or you can just remember it.
Or you can just remember it.
What's an example is a graphics card applying the same
Yeah,
instructions.
CISC versus RISC.
Oh,
Go.
Jesus
Oh,
Christ.
kill yourself.
No!
Which
I
one
can't see that.
Let me write it out.
I'll just cry.
Okay.
CISC, many
Okay,
addressing
wait. Hold up. Let's write them in a nice list.
I've got a
CISC.
cute table
Why
I
don't you
made
get
up.
Word? Because you get Word up, Alex. It'll be a lot
CISC
easier.
uses multiple machine cycles.
Addressing nodes.
Lots of
Because-
addressing
no.
nodes.
Because this doesn't. Because many. More expensive circuitry.
Yeah, more expensive. Is it harder? Is it harder or easy to program?
I don't think that's a. You know how to spell circuitry.
Yes, I do. Just
Yeah, I think it's easier. Jesus Christ.
it's easier to program.
It's easier to program a more complex program. If you had RISC and you're trying to that program,
No. Also,
Honey,
no.
did your fingers slip, Alex?
Yes,
No,
my
more
keyboard
complex
oily.
instructions available.
Yeah. So that's
Yeah.
why it's easier to code a complex
So
program.
yeah, I need to go in a minute.
Okay, fine. Me and Ben will take over, and I'll invite Caudle when you go.
Okay. Yeah, that's pretty good.
I like it. I think we're good. Co-processors. Do you know about them?
No, RISC.
Oh, I'm sorry.
You need to get in gear, Alex.
But RISC is pretty much
Do you
the
want a Word
opposite.
document?
No.
Cheaper,
Cheaper. Yeah.
less complex instructions.
Instruction.
Usually
Faster
for a
machine.
specific use. Usually
Uh-huh.
for
Yeah, more specific.
use. What else? Faster.
Faster.
Honey!
Yeah, that's it.
Uses a register set.
You
Registered. Has a processor. Uses a processor.
No. About co-processors. These are nasty little buggers.
No, they're not.
What can you say about them?
A coprocessor is a system which it's not quite parallel.
Not
It's
quite
basically
concrete.
no. In a coprocessor system, it's many processors working on the same task, right? With different parts of the data.
So like a graphic card.
No, because it's many processes. So let's say you have maths coprocessor. It'll take different parts
I
of
remember.
that problem and work on it separately. Well, a parallel processor has a more complex OS that allows each processor to do a different thing. Okay, I need to go
Yeah, so
now. I'll be
okay, you
back
go.
online in a
I'm
tittle
going to
week.
invite Caudle.
But BT dubs, BRB, HGA.
Let me invite Caudle, Ben.
Sure. We should go over the 3 normal forms as well, because that's the,
Yeah, I don't think there's not much you need to know about them.
Well, I just know about.
It's the third normal form that you need to kind of.
Oh no, the third normal form's the easiest.
Yeah, you don't really need to know about the others.
Well, first normal form is just atomic.
Yeah.
Second normal form is no partial data dependencies in the table.
Mhm.
Third normal form is no attributes in the table. That there shouldn't be any attributes in the table that are not related to the primary key.
Yeah, they all
should
have to be
separate.
dependent, and also they all have to include each other.
Yeah, exactly. You can't have third normal form without first or second.
What do I want to do? Let's have a look.
Maybe linking. Oh, so remember that an ER diagram can't have a many-to-many relationship between the
You
tables.
need
So
intermediate tables.
linking entities. I don't know. It's just.
What else is there?
Well, I guess once Caudle joins, we could do a bit of reverse Polish with binary trees and.
Caudle hasn't read the message, so hopefully he'll.
Oh, I know. Differences between a static data structure and a dynamic data structure.
Let me delete this. So I remember doing this. I said that the static data structure is fixed in size. It's easier to program. It's easier to detect any overflows.
Yeah.
And what's it called? A dynamic data structure is harder to program because and in static also the programmer has to guess what size he'll need.
Yeah, that's a disadvantage. Yeah.
Yeah, that's a disadvantage, and I mean some advantages of dynamic are it makes more optimal use of the memory.
Yeah.
It's also, I mean, the disadvantages are it's harder to program. Caudle's seen it, so he's probably joining.
Sure.
It's harder to program. What else is there? It maximizes use of memory. I can't think of anything else. It can change size, which is a fundamental thing.
Yeah.
Let me think. Yeah, that's it really. It only uses the space it needs.
Well, there's also it can be slow to implement searches. I'm presuming because if it doesn't know how big it's going to be, it's got to check so how large the data structure is. Also, a linked list only allows for serial access. I guess it. Yeah, I'm not really sure about that point actually.
What one?
About the use of a linked list.
Oh yeah, I'd ignore that. I don't think that's particularly
Oh, I'd like a good question on a push or a pop algorithm.
Oh yeah, that would be nice. What else can we do?
Pre-order, post-order, and in-order traversal.
Yeah.
Tell me.
So pre-order is where you start at the root node, you go left, then you go right.
Yeah.
In order is you go. It's left root, right.
Yeah.
And then post order is left, right, root.
Yeah. Just remember it as if it's pre, then it's the root node first. Post, the root node last. In, the root node is in the middle.
Mhm. Oh, I like that way. Yeah, that's nice.
It made so much sense, and it means that obviously because when there are questions quite often on when they have a binary tree and they want the reverse Polish, virtually certain the next question will be what method do you use to obtain the reverse Polish, and it's just saying post order traversal.
Yeah.
Should we get Caudle to go over quicksort because he was good at it, and I'm virtually certain
he can't join.
Why not?
He says he's having technical difficulties.
Oh, that's classic.
But I like quicksort. I can explain quicksort.
Yeah, go on.
Let me write out a list. So you have Caudle's going to be so upset he's missing this.
Because in the revision guide, they show it like one way, where you move everything to one side, move everything else to the other side, like with a fixed point. But then it talks about moving items to the correct side of the pivot, and that just confuses me.
Okay, let's see this. Let me space these out nicely. So you have a list of unordered numbers, and you select an arbitrary pivot point. So it's normally on the first data item. So this is a fixed pivot. So this doesn't move.
Right.
You then take another point, which let's see in the textbook. I think they normally just pick the one at the other end.
Yeah, it's normally that.
So they pick a movable head, a movable pointer. So what it will do is it will first compare 6 and 1 here.
Yeah.
6 is greater than 1, so that's fine. So it can. Oh my god. So it can move on to. Oh, this is actually quite cool. So this will move on to the next data item, which is 3. Oh no, we're going to be stuck with 1, so it's never going to switch. Let's change this number to a 4.
Yeah, something in the middle.
Yeah, because now we can have a switch. So what will happen now is your pointer will be on 3.
Yeah.
It will compare 3 and 4, and obviously 3 is less than 4. So
Yeah.
it will switch 3 and 4 around. Oh, this is going to be so hard to draw. So we'll switch 3 and 4 around along with their pointers. So,
Yeah, so the 3 switches and the 4 just swap around.
Oh my god, this is so cool. And the 4, look at that. And I'm going to have to change the direction that the arrows are facing.
Yeah, but I get what it is.
Yeah, wait, let me see if I can rotate. Oh my god, I can.
So happy.
Paint, water. So they switch. Now,
Right.
this pointer,
Yeah.
I'll take it again. This pointer will move. Kill me. It's so hard. Ah! Paint, get your stuff together. This pointer will now move 1 to the right. Like that.
Oh, you're gonna have to swap it around again.
Oh Christ!
I get the idea though.
So you keep swapping. So basically, what will happen is it will make 2 new unsorted lists. Should I carry on to show you the end product?
Well, I know what the end product will be, but what do you mean by 2?
Oh, I'm
unsorted
gonna have to
lists?
do it by continuing. Just let me try and. So 5 and 4 are compared. These are swapped. There's no other way to do it, but with 5 and 4 are swapped. Oh, Jesus Christ. This is the most shambolic quick sort ever. Rotate. Okay, so that's good. Oh, good. Okay, we're coming to the end. This can move again to 10. 10 and 4 compare. 10's greater. 7's greater than 4. Then we get to this stage, and they need to do one last swap. Oh yes, this is the best bit. This is the most exciting bit. So, obviously we do the swapsy again.
Yeah.
4 there, 2 there, 2 here. This is the most beautiful quick sort. So that's correct, and then basically this will move again until the pointers are together. And as you can see, there's 2 unsorted lists, this side and this side.
Oh, so the 2 unsorted lists are the end product either side of
Yeah, So what you have to do is you have to run a quick sort again on those data items.
So we'd have to do that in the question so that we end up
Yeah.
with. Right.
Yeah.
Oh, I see. Because the example that they've used in this question, in the textbook, the revision guide, they've used one that would end up being in order.
Yeah, they probably would in the exam. I'd hope they would. But
Oh no! It says at the end, this is where we take the list 1, 2, 7, 8, 6 and recursively sort them as
so
prescribed.
it's a recursive sort.
Okay. Cool.
So
All right. That makes sense.
And there's also insertion sorting, but that's the easiest thing.
Yeah, that's just comparing the two
Normal
items. If the one's bigger, then you put it in, and the other one's not.
Yeah, pretty
And
much.
actually, it's not moving them. Right, when you're comparing them, it's not actually moving the item over. It's just moving the pointers in the list so that you're comparing two different items. Like it copies it over, but it doesn't delete it from that list. So
yeah.
That's just merging data. Difference between binary and serial search. There was a question that came up about that.
Oh, I love. So that's just where binary in each pass of the search will halve the data it needs to search through. So it will look at the center item of data and compare the data it's looking for less than half. You know, just what is happening.
What's a disadvantage of binary searching?
Very inefficient for small amounts of data.
And it has to be ordered as well.
And it has to be ordered, yeah.
Otherwise, that doesn't work.
Otherwise, you can't do it.
Pretty much swag.
Wait. What sorting needs it to be in order?
Binary.
Binary search, sorry.
Because obviously, when you compare a middle point, place or low.
Brain fart. Oh, do you are you any good with BNF?
BNF. Yes, that's unambiguously defining the syntax of a programming language.
Yeah.
Okay, I think. Let me just check that I'm not getting confused. BNF. Yeah, and BNF can be represented with a syntax diagram, can't it?
Yeah.
Yeah. Okay. Yeah, I get those. So that's just basically. So it has different.
Yeah, I mean, is that not hilarious? You stop chatting on Facebook.
Yeah.
Oh my God, no.
I'm going to go by 10:30. We have the potential to get through databases very, very quickly.
Yeah. Okay.
Who is he talking to?
Is he a reader? Hello?
He's muted himself. Okay. Anyway, let's just continue. Yeah. So with BNF, it'd be easier if I showed you how BNF works on Master. I've got Paint and Paint.net.
I know how it works. It's just
Yeah, the thing about like defining what a letter is in a programming language. So it'd have letter, then a colon. Is it colon equals?
Yeah, it's colon.
Colon equals. Then so you might have like capital A, and then there's a line, capital B, line, capital C, whatever. You can also have like an iterative. What's it called?
Oh wait, you mean where you use that way? It's like where you use its own definition as defining itself.
Yeah. So they're like an example where if you're if it's like a staff code, for example. So you've defined what a letter is, you define what an integer is. So then you've got so then in the staff code definition, you've got say letter, then integer, then the line, so it can be defined also as staff code and integer, meaning that it can be a letter and then any number of digits following it.
Yeah, why the hell are we feeling so bad about this exam? There's nothing that we've come across that we don't get.
Because computing, because we haven't, I mean, apart from John, beautiful saint, we haven't had a teacher, so it's like learning this whole course for ourselves, so we don't feel prepared.
Yeah, I guess.
No, you're right. Like, there's nothing here that we don't understand. All it takes is thinking through, make sure you're talking about the right thing, and
okay, let's Let's try and find some really nasty stuff. I mean, there really is.
Maybe a question on. There was a question on declarative programming.
Oh, I heart declarative.
I love it, but there was a question like about I can't even say it.
Instantiation.
Yes, that
Stan-
word. Like define it and give it an example. Again, it was the June 2014 paper.
So sure, instantiation is like in the book. It says like cat Tom. You're instantiating Tom as a cat.
Yeah, it's basically. She just said it was just giving a variable, defining the value of a variable. So yeah, in this case, like if it was cat x where x equals Tom, then you're defining the variable cat. You're assigning the value Tom.
Yes.
Then obviously the backtracking is if a rule is found that satisfies the goal. Hang on.
If a solution to a goal is found.
Yeah, if a solution to a goal is found, then I get confused between the goals and the rules.
The goal is the objective, so like cat X, so it will search for all the cats X, so the
Right, okay.
But the rule is if you have more items of data, you have to show how they interact. You just need to identify one, really.
Oh, so a rule is okay, so fine. So a goal is just applying the rule to the facts.
Data.
What they call them.
Give me a second. Let me close my door. My mum has decided to blow dry her hair. Darius is off to Israel tomorrow. Lucky bugger.
How come? A toy?
Who else spoke there?
No one. It's just me.
Oh, phew. Oh, because he's on Atoll, yeah.
Oh, wow. Very lucky. My sister's got her last exam tomorrow.
Tally had her last exam today.
She's got
How
dance.
envious I am.
And my sister is currently at a friend's house burning all of her past papers.
Mature, I like it.
They're having a bonfire, like she's taking snacks and everything, and they are burning all of their past papers.
Jesus. That is something I'd like to do.
Well, it's fine, Alex. No, because we're 18, we can drink legally. We'll just drink our sorrows away.
Yeah. Okay. We're good at this. What else is there?
Okay, so
We're good here. We are very good.
let's just run. Because the thing is, I always get lost with is remembering stuff like what memory management does, the purpose of scheduling, the purpose of an OS. I always either get them all confused or just don't remember enough of the points from them.
Yeah, that's
That's I've just got to read.
Yeah, I mean that's just read.
What does a high-level scheduler mean?
I hate when you say, I can tell you're trying to screw me over. Go on.
A low-level scheduler do?
What do they do? A high-level scheduler, his job is to load a job.
Scheduler. We're speaking the Queen's English. Scheduler.
Sorry, a high-level scheduler loads the job into the ready queue. The low-level scheduler loads a job into the ready queue, and a MLS medium.
The low-level scheduler transfers the job. Well, there are so many different definitions. Well, you said the high-level scheduler transfers a job to the ready queue, which is correct. Then you said that the low-level scheduler does the same thing.
No, I said it moves jobs from the ready queue to the running queue. No, I didn't, but I meant to say that.
Yeah. There are so many definitions. Some places will say into the running state. Some say it goes from the ready queue into the processor, which I guess the running state is in the processor, and then the medium level scheduler is just between the memory, the primary memory, and the backing store.
Yeah, and then the MLS moves primary memory backing store. So does that basically just coordinate virtual memory?
No, it just coordinates the movement of jobs from the backing store into the memory then into the processor. It's just the movement of the jobs. Preemptive and non-preemptive.
Oh, preemptive is where it's able to move jobs out of the running queue, and non-preemptive, I don't know what it's called. Non-preemptive has to wait till the job's finished.
And the disadvantage of non-preemptive being that it can monopolize the processor if it's a large job that's entered the running queue. Medium level feedback queue in this revision guide is explained beautifully.
Yeah, it's great.
It just makes so much sense in this queue.
You know what time Darius has to wake up? 2.
Oh, that's grim. 2?
Yeah.
So, what time's his flight then?
Early in the morning.
Well, when I go on holiday, we've got to wake up at 2.
Yeah, we normally wake up. It's the best feeling.
I don't even care if I'm tired because I'm just so excited. It's just like,
yeah, I know it is.
Oh, it's so close as well. Like, I go away in under 2 weeks. Under 2 weeks.
Under 2 weeks.
In 13 days. By now, oh my god, I'll probably be
God, yeah.
Literally, it's under 2 weeks. I'll be incredibly drunk, probably walking along a beach somewhere. Oh.
And then up in Syria.
Yeah, exactly.
This is on the live stream, so it's immortalised on YouTube forever.
Can you imagine if they show this to Mr. West?
I'm gonna show this to Leeds, see what they think about this bed.
I'll show it to the computing department then.
They'll be very impressed by my quick sorts.
I'm sure they will be. I'm sure it's actually a lot more complicated than they're making it out to be.
Do you know the difference between segmentation and paging?
Well, funny you should ask. So, paging. Okay, so first, basically, they're indexed, so it allows the processor to.
Both are indexed, aren't they?
Yeah, both are indexed. Paging is when the memory is split up into fixed blocks.
Mm-hmm.
So obviously the jobs are split up into the pages. It's very mature there.
Yeah.
So they're split up into equally sized blocks. The pages can be moved between the primary memory and the God, why is my brain not working anymore? Virtual memory, yeah. So the primary, so the pages. A disadvantage of paging is the fact that code could be split up within a construct.
Yeah, and is that, and also if a page isn't filled up, you're going to waste memory.
Yeah, John didn't like that.
Why not?
He said that the chance of that happening is so rare that it's not even something that's generally considered.
I guess it would be rare, but
it's in the book. It's in the book. Let's put it that way. Also, disk thrashing or threshing.
Oh yes.
In the same thing. Just processor spends more time transferring jobs between primary memory and virtual memory than carrying out actual processing. But then segmentation, the code is split up into variable size blocks.
They're on logical lines, I believe.
So like end of constructs and whatever. It means, I guess it uses the primary memory more efficiently.
Yeah, I get.
Well, yeah, because it's only using the space it needs. Whereas, like you said, if a page contains like a piece of code or a job that's smaller than the page size, then it's wasting unnecessary data.
Mm-hmm.
So the segmentation. What else can you say? Segmentation. It's logical blocks. It's variable. Again, it's indexed.
Fixed size. The segmentation varies in size.
Pretty much it. I mean, we've said about 6 or 7 things. So, fat.
Well, we both like fat. Fat is good.
So, talk about linked lists having. So it shows what parts of the hard disk are occupying a file. So, in the linked list is a table, isn't it?
Yeah.
So it's got the file name. And then it's obviously got the cluster, the cluster number, and then it's also another column for the pointer, and the pointer just indicates the next cluster where the next part of the file is located on the hard disk.
Yeah, it stores file names, access rights, free memory, protects reserved spaces on the disk.
Is this the file allocation table or the linked list?
The file allocation table.
Right. Okay.
It protects sections of the disk used every time the operating system is used or updated.
It's loaded onto the RAM to stop frequent hard disk access.
I like it. Yes,
that's
the
a
RAM.
good point. I like that one.
It's loaded onto the RAM. It's a good one.
So it also has sort of, you said, security measures, data validation. Does it have data validation as well?
Why would there be validation on a FAT?
Actually, no, I guess not. So it's used by the OS to update.
Yeah.
To locate empty parts of the hard disk that can use. I will go over this in the card tomorrow because I want it to be fresh in my mind.
Fair play, fair play.
Do
you like my artwork?
Yeah, it's very, very beautiful. I like the green arms.
They're it's like meant to be a tree person.
Okay.
Let us think of the most nasties.
Talk about tokenization in lexical analysis.
I like it. So each keyword is in the lookup table. They correspond to a binary token, which is the binary corresponding value. So in lexical analysis, it takes a keyword, replaces it with its corresponding token.
And what is the key, like the thing that corresponds to the token called?
The thing that corresponds to the token.
So like for example, the identifier. The identifier is called. It relates to.
It's a keyword.
Yeah, but what's the thing called?
A mnemonic.
Lexem.
Depends what you. A lexem.
Yeah.
What the hell is
a lexem is basically.
They put it in the revision guide. This word.
Yeah, a specific group of characters that represent the token. So, like, if a token type is identifier, then the lexem would be squid, for example.
Yeah. So it's the same thing as a keyword.
Yeah.
A keyword and lexem. What else is there we can do?
And then syntax analysis does semantic checks, so like flow of control, checking that any declared variables are actually used, even though that's sort of a logic check.
Oh no, checking variables are used is in code optimization.
Is it? Oh no, sorry, I was confusing it with declaration checks, making sure that they're all properly declared. Flow of control. Lexical analysis is obviously the slowest form of code, sort of I don't know what's it called, like translation or checking.
Yeah, translation.
Compilation, because it deals with the code in its most abstract form. Generation, optimization. Get optimization. Generation, I'm a bit rusty.
Generation is where it just takes all the binary and actually converts it to its low-level language.
Right.
So that's all it is. It just takes the binary the rest of the steps have produced and converts it into the pure machine code. That's the only thing.
Cool. Okay. Symbol tables.
Oh yeah, that's for labels, isn't it?
Yeah. So it stores the identifier of a variable and also its memory location or the binary memory address.
And its data type and name.
But also when it gets too long, it's stored as a hash table, obviously with a hashing algorithm, like in F453. Got library routines. pre-written.
I do like
pre-
I got
library.
nothing but
Oh.
being creative. I did. Yeah.
Nimrod, mate, you have missed.
Oh, really? Is it about the MAC addresses?
What the hell are you talking about?
Why is Daniel Cordell muted?
Because he was being naughty.
I don't really want to learn the other
Yeah,
way
you-
of quicksort because
I do pivot. I do pivots by like circling things.
That's
that's
one way of
basically
doing
like
it.
well, no, it's the same way as Oz. They're just
Yeah.
using circles instead of arrows.
You've got arrows instead of circles, mate. So
Yeah.
Jason, don't apologise. I'll tell him it's been very successful.
This has actually been incredibly productive.
Yes.
well, I see a picture of a tree. So
No, I was just drawing for the
entertainment.
entity because we've done.
viewing?
It doesn't matter.
Of course it does.
Jason's glad. Oh,
We need to make the YouTube money.
it will get monetized
I
when it
need
goes
a
live.
diamond play button, Alex. Get me that 10 million.
Yeah, you need to fix a dozer.
What's a procedural programming language?
Oh, it follows the same route every time, made up of blocks of code called subroutines / functions or procedures or whatever.
Yeah.
And it is used it follows the same. It goes through the code line by line, executing each line.
What's it called?
Oh, it's an imperative programming language.
Yeah, exactly.
What page is that on?
Oh, your mom's page.
36.
Nimrod, I was just telling Jason how great you've been behaved.
Well, then why do you stop?
We've covered basically the whole course.
Yeah,
What does it mean by imperative?
relational databases?
Nimrod, stop being so noisy.
Do you cover relational databases?
Yeah, we talked about views, different forms.
You missed all of it.
Data duplication.
Yeah.
Easier to update data in a relational as it only needs to be done once.
Yeah.
Crazy. But what about mail? Did you revise
Can
mail?
somebody explain the procedural languages bit?
I just told you. It's
Yes,
an
but
imperative. It's
What
an
is imperative?
Don't worry, but imperative.
Just know it.
Listen, imperative. You know what the imperative tense is in language?
No.
Okay, imperative. If I say something to you, it's
Oh,
imperative.
you must.
You must do it.
Yeah, you must.
So imperative language means what you type must be done. It's not like a declarative.
What happens if it's in what happens if it's in a conditional loop?
It doesn't matter. It still must be done, right? But it's just not. It like the condition. Everything you write must be done, right? Obviously, conditions skip past bits. But in a like let's take the example.
Oh, okay, I get it.
In
I
a
get
flat
it.
file with no conditions, it will do every single thing. A declarative language doesn't need to do every single thing.
Yeah, I got it.
It
Got it.
goes through depending on like input space from before.
And what's
Using rules to determine a goal.
Jesus Christ? You're in the live stream.
Yes. Broken Google Hangouts.
It's broken Google.
So if you integrate lin x, what do you get?
Isn't it x ln x minus x plus c?
Yeah, I think so. Minus x, yeah, something like that. You
Take
just
it.
need to do x ln. You just do write ln x as e to the ln x, right? Oh no, you write it as
I believe this was a computing.
e to the x ln 1. Something like that. Something like that.
What happened to my sharing?
How'd you get that idea? Alex,
What?
how'd you get that idea?
I just tried to think creatively.
What do you see when you look at this orange?
What have you done, Alex?
Orange. Sorry, yeah, it's. What else is there?
The different levels, internal, conceptual, external.
Yeah, let's quickly have a look at those.
Which is simple. External is the views, talking about the views. Conceptual is viewing all of the data from all of the tables, sort of in
Wait.
one table.
Wait,
So
what are you
might-
talking about? Conceptual?
And external.
database architecture. So external being the views. So we talk about those. Then the conceptual is viewing like the data from all the tables on sort of like one screen. So it's used by database administrators. And internal refers to the way in which the data is stored on the hard disks, which is that's normally hidden by the database management system.
Have you gone over reverse Polish?
No, we have
We
not.
haven't.
Ooh,
Okay.
not the whole course yet.
Try and get up a question
What
with binary trees, because
Other than a binary tree, what other data format?
An array.
is-
An array.
No,
a stack.
stack.
What? Oh, sorry. You were talking about
Yeah.
reverse Polish.
Getting
I was
ahead
still.
of
I thought
yourself.
you were talking about binary trees because they can be done in arrays.
Yeah, with pointers for
Yeah.
the indexes.
Lists.
Let me try and get
Right?
some reverse Polish. Yeah, linked.
Just convert u plus t
Yes,
times x.
Mean dog. Mean dog.
Alex, just differentiate a to the x, okay?
Oh yeah.
Simple.
Risk, sisk, blah blah blah.
Oh,
Okay.
I remember how you integrate Linux. You need to pretend that it's u dash v, right? You do it by parts, but you need to pretend one part is just one.
Ah, yes, you're right.
It's
'cause
one
then
times
you,
Linux.
yeah, because then you can differentiate the Linux.
Linux and integrate the one.
Oh, yes, that's right. Do it.
Okay, I've got a binary tree.
Right, Alex, you remember how to do C4.
I do. June 2011.
Do you even know how to
Wait, Nimrod. They told us we needed to do maths A level for physics.
Do you even know how to integrate?
Yes, of course.
Are you sure?
Yes.
Yeah. Oh, yeah, you would have done it in AS, wouldn't you?
Yeah.
What do
Integrate-
you know?
T. DT.
Integrate DT.
No, just T by DT.
What?
Just integrate T.
Half t squared.
Oh my god, it's for Alex. It's not for Ben.
Half T squared.
We should give him some implicit differentiation. Try and get him to reorder that.
Okay, I've got a nice binary question up. Okay, I don't want you calling out the answers, especially you, Nimrod.
Binary.
Fucking communist.
Binary or reverse Polish?
Martian.
Oh, I did this question with John today.
Shut up. I want to hear your answers individually.
PQ plus
Shut
RS
up!
minus
Shut up! Nimrod. Shut up! Do it by
PQRS
yourself.
minus
I'm not-
plus.
Shut up.
Yep.
Okay, there's two ways you can do this.
There's two ways. One of them is called the purest way.
Yeah. Yes, the purest way.
Oh,
Nimrod, has John talked to you about the purest way of output?
No.
Well, I'll tell you the impure solution is PQ plus RS minus times.
Well, that's the right one, so.
Yes, but there's a purer method
What is that?
where all the signs go at the end.
Oh yeah, but that's so annoying.
Yeah.
Because then you need to reorder it. You just do post-order traversal.
I'm just imagining the way John constantly goes on about the purest way. I'm just dying.
Purest form.
Ugh.
What else is there?
PQ plus RS minus times.
Yeah, got it.
Post-order traversal.
Here's one. Convert. I'll just make one up. Convert.
Can you do it on a Word document? So you don't. It's
What the hell is your obsession with Word? P plus Q. Try doing this. Convert that to reverse Polish. A nice little starter question for you.
PQ plus 3 times.
Yeah.
Congratulations. Do this. Convert that to reverse Polish.
Nimrod sucks dick 3 times. I see what you did there.
Yeah.
That was intentional. You can't have been knowing Alex. It can't have been intentional.
It was intentional.
Oh really?
It was.
Now do reverse Polish
Do?
into real.
I don't know what okay,
Infix.
No, reverse Polish into infix.
you give me a reverse Polish.
PS divide. Oh no, PS.
Plus
No,
Times.
T. PST plus minus.
PST plus minus.
Yeah.
Okay. So that's
S plus T in brackets minus P.
Nice
yeah,
one.
times P.
Well, that's it. That's all you can know.
How about let's do this one? QWE divide times
So that's W over E.
times Q. Very good, Nimrod.
Wow.
100%.
How about
Are you driving in tomorrow?
no? Ben is taking me.
He finds driving stressful.
Oh, of course.
Nimrod, what does that spell?
P times U divided by CI.
Okay, I like it.
My brain hurts.
How long have we been going for?
Probably two.
Nearly 2 hours.
Well, 9:30 will be 2 hours.
What a successful session.
Let me have a
Keep it
look.
up, keep it up on, share it on the group, the video of the whole thing, and then everyone can learn.
Charlie wants it.
And I can watch the stuff that I missed out on. I'm so eager.
Oh yeah, we did quick sort and some day-to-day. That's yeah, searchings.
Oh, can you just write, we teach better than West?
Well, I never did that in the first place, so I don't know why you
This
come
is
up
a
with
cheeky
that
one. One example of an interrupt after which processing is resumed.
Printer is
I-
out of paper.
No, the best one is an internal clock.
Printer is
I
out
have
of paper.
interrupt. But
Software interrupt.
a hardware interrupt would not, because the computer's crashed.
Printer is out of paper.
Timer interrupt. Software interrupt. A timer interrupt by an internal clock.
No printer detected. Interrupt.
The computer has not been turned on.
Error cannot connect to the internet. Interrupt.
Error, computer is not plugged into socket.
Wait, TCP sockets or UDP sockets?
UDP.
Okay, good. So Alex, how do you work out the luminosity of a star?
Luminosity equals sigma t to the 4 pi r squared.
Right.
How do
What
you
is
work out the Nimrod, calculate the age of the universe?
13.92 billion years.
V naught equals h naught t naught. So h naught is 1 over t naught. T naught is 1 over h naught.
V equals HD.
Yeah. HD naught. So t
H
naught.
naught D.
T naught is 1 over h naught.
Yeah. It's the gradient, right? Or something like that.
Yeah, something like that.
Yeah.
Don't worry, I've got like 6 days to do as many
Yeah.
P5 papers. All of them.
I tell you what. After this exam, I have 2 left.
Same.
Oh, you're so cool.
There's 3.
But I'll let you know what freedom feels like, Alex, on the 27th, whilst you're still crying into your physics book.
Trying to work out the age of the universe by the velocity of the moon on a Wednesday evening.
Oh my god, that's actually true.
What?
What?
Not for real. You see that skateboard, Doc Winters, Fuzz, yeah.
Alex,
Yeah.
they don't want us to get an A star in this computing exam.
They don't want us. No siree. What else is there? What else is there?
I didn't realise I've got to. Do you remember we had that day when these people came in and they tried to make us do stuff and they gave us power banks?
Oh yeah, the
I've
Israeli
still
people.
got two of them sitting
I
in
remember.
my drawer.
I've disassembled one of them, and the other one's on my desk.
2,000 milliamp.
Yeah, it doesn't charge my phone.
He used it for nourishment.
Nourishment, yeah.
Yeah, you drinked the milliamps.
Drink.
Yeah.
When he gets tired, he kind of has brain farts.
Really, Alex? How do we spell circular or circuitry?
Circuit.
See?
Rizzed. Time is a tool.
Time is money.
No, time is a tool. Or something you can wear on your wrist.
Explain the purpose of intermediate code.
Oh yes. Architecture, portability.
You said it. Just portability, I'll accept.
The programmer doesn't get stressed having to compile
That's a nice
code
one.
for every architecture.
That's a nice one. That's a nice one.
Programmer is already stressed from writing code.
The programmer has realised he picked the wrong career.
Yeah.
Jesus.
Linkers, loaders, loader, linker.
Library routines make it
Blinker,
easier to
blinker.
steal people's code.
I think
Give an
we're
example
ready.
of a virtual machine.
Java.
Java. Yeah, Java.
Java.
Oh,
We're ready.
Yep.
you say that, but they're going to give us a question tomorrow.
The entire paper is UML.
I'd like that.
No, you wouldn't. You wouldn't.
UML is on lockdown. There's only 7 diagrams we've got to remember.
Do you remember the shape for an input in an activity diagram?
Yes, it is. It's a
It's the most
rectangle with the indented triangle bit,
yeah.
and an output is
Yeah.
the one that's got the pointy, like the pointy bracket.
That is correct.
Swag. Describe how a jump instruction is executed.
Oh, I don't know.
Oh no.
Okay, PC loads the.
Yeah, I remember.
PC to MAR to MDR to CIR to then to
MAR.
PC again. Yep, that's it.
Done, 100%.
Wait, what was it? It's PC, MAR, MDR, CIR, back to PC.
I thought it was PC,
I thought it was
MAR, CIR, MDR.
Well, the MDR is used twice.
Yeah, but isn't it not PC, then MAR, then CIR, then MDR, then MAR?
No, it has to go MAR, MDR, CIR.
Yeah, because it
MDR,
needs to load the stuff from the MDR.
Oh, so it takes the instruction that's in that, loads it into the CIR, then
Yeah.
it takes the memory address, puts it in the memory address register.
Surely the CIR would have to send its data back to the MAR, MDR, then PC.
English?
No, it just loops back round.
Fine, it just loops back to PC.
Executing, it
Cool,
just goes
cool.
back to the PC
Fine.
to start again.
So what's held in the CIR are just the jump instruction
The jump and the address.
and the address, yeah.
And you just load the jump instruction into the PC.
Yeah,
Yep.
no,
Well,
the
the
jump
address of the
instruction
jump,
just
the
tells
address.
the processor to just
Yeah.
go back to the PC with that. Yeah.
Address, the new address. Mm-hmm.
What's the purpose of an ALU?
Oh no! Oh, no! Please! It performs. There's a mnemonic here. A for arithmetic. Shut up.
No,
It's just an arithmetic logic unit. It holds
Wait.
the results from the accumulator.
No. Arithmetic,
no,
logical
sorry.
comparisons, and gateway to the CPU.
I meant the accumulator, but well done, Alex.
Thank you.
Apply cold water to that.
Intermediate values of calculations.
And
And
I/O stuff.
is it used for I/O?
Well, yeah, that's what the Marxian said, because I knew the intermediate values for mathematical calculations,
Yeah.
but it's also for I/O or something like that.
Fair play to the lads. Fair play. Let's see if there's any predictions on the student room.
That's a good idea, actually. I'll second you on that endeavour.
Give me. I'll be right back in a sec. Give me a sec.
Baba Ganoush and Absa Stray.
Official thread. Oh no, that's 2012.
Okay, here's a thread.
Send me a
They're
link.
panicking about UML.
Pat, send me a link. Send me a link. Send me a link, god damn it.
This is not rocket science.
No, you're not. You're quite right. That's in physics.
Have you found it?
No, I haven't. Send me a link.
It's on Facebook. I hate every time you have to sign up.
You have to sign me. Do you know what my name? My name is GCSE Ben
Oh my god.
because I made it. I made it when I was. Yeah, that would be great.
There's
Virtual
literally
memory.
people advising people to learn HTML for this exam.
I'm like, yes, there is a UML support document.
Yeah.
One of the ones you would expect to create, since interpreting is something you can do. You can sort of do on the spot.
Here, I found
Right.
some predictions.
Wait, what were you discussing?
I'll tell you the predictions.
They're learning languages for the exam.
Let me tell you the predictions.
Wait, can you send the link to me,
No.
please?
Fine. Okay, so one of the predictions is describe algorithms for the insertion, retrieval, deletion of data
Hang on,
items.
where are you looking at the predictions?
52 minutes ago.
But thank you, you're so useful.
On that thread, 52 minutes ago, it's around that.
Yeah, well, what page?
14.
It was on 14. This is an hour ago. So it has to be 13, because that would be 52 minutes.
No, it's on
ago.
page 14.
You're drunk. You need to calm yourself down. Get out of reverse gear, Alex.
I hope they did.
Wait, yeah, the algorithms for inserting and deleting a file, an item from a keyword stack.
That's very easy.
Then what was it? What were you talking about?
Oh, do you know how data is deleted from a tree?
Yes.
I like this one.
The node is marked as
Yeah.
deleted.
Or you can rebuild.
Yeah, but
Yeah.
it's normally just marked as deleted.
Yeah.
Because otherwise, you need to rejoin everything.
Yeah.
Yeah. Oh, I don't see where these predictions are.
Page
is it?
14.
Is it? Hang on. 53 minutes ago.
Go on to page 14. Go on to page 14.
Yeah,
Mhm.
53 minutes ago. What is sleep?
Yes,
that
what
the
is
guy?
sleep? Yeah.
Okay. Norm, see many questions about data calculation. Describe algorithms for insertion, retrieval, and deletion of data stored in stack queue. What about retrieval?
Oh, retrieval in a
Oh.
tree structure.
Yeah.
So basically, what you need to do is you just write an algorithm. It goes through. Is the current? You need to talk about pointers. So you say set pointer to current node, right?
Yeah.
So if the current value at pointer is greater than the or is less than the wanted value,
Yeah.
you traverse right. Else traverse left.
And then do you move the pointer to that node?
Yeah, and then you move the pointer to the next node. You just do it until the value is found.
Yeah.
But you need to talk about moving pointers. That's like a couple lines.
Okay, cool.
So wait, the pointer's set where initially?
The root node.
The root node. And then
The assumption you make is that the data does not appear is not already.
yeah.
It's not. It doesn't appear twice. Or
There's
is
literally
there at all.
people asking to explain classes and objects.
Yeah, Alex. Not everyone is as smart as you. Okay.
Not everybody's as smart as you.
Oh, thanks, babe.
But Ludo sure is.
He's not a dog.
Your dog is adopted. Adopted.
Oh my. Can anyone explain to me what a class and object are?
Then-
Can't get my head around it. Poor Aaron. Poor Aaron.
Poor Aaron.
Imagine if they ask a question about the Data Protection Act.
Well, I did F451
Oh yeah,
again.
because you actually know about that. I have no idea.
Yeah.
All I remember is errands too, but for the life of me, I can't remember what they stand for.
Errands.
I listen F451.
What about F452? What evil numbers?
Oh, it was a pretty interesting paper.
Was it hard or?
It was fairly hard, yeah.
In one of the university applicant groups, somebody goes, "I'm 3 days too young to write in the referendum." Some people are like, "I'm 2 days too young. I'm 1 day too young." Some Indian guy goes, "I'm too foreign."
Why are you on these AIDS groups?
Because they're so
Well,
funny. Because all
like,
they talk about is a
Ooh,
referendum.
let me see if there's a Durham applicants group. Durham.
Why would you go on that?
Oh, that's an excellent question. Durham.
Alex, I don't get it. Look at this picture.
Do you want to meet up and play lacrosse? Oh, what, Nimrod?
Look at this picture I sent you.
Yeah, I've seen this meme. Oh no. You know Gatis Candice? He's uploaded
Oh,
a
yeah.
video about how to save money.
Yeah.
No. How to save time when you walk through the door, or
Yeah.
step over the log. Step over the log, rather than stepping over it. Step
Ooh.
through it.
Talking about stepping, F452.
Don't.
I didn't do it, so I don't know what you're talking about.
Oh, goody. I don't know what else. Anybody for some binary questions? I want to do some.
Come on, fire it at me. Let me see that sexy Mantissa.
Jesus Christ, Lord above.
Yeah.
Poor Mantissa.
This video is hilarious.
Okay, do the questions. Please don't say them out loud.
3.
Here, okay. I am going to... Calm down, Ben.
Alex, what's your view on aspic?
Aspic.
Mm-hmm.
I have no idea what it is. Now let me do these binary questions.
First one's 3.
Oh, Ben, shut
3
up.
was. I got the first answer to the question without even seeing it. I'm a genius.
No, I don't even know if it was 3.
It was 3. It is 3.
Okay, shut up.
It's 0.11 plus 2.
Yeah, so you move it 2
3.
to the right, 3.
Yes, I
And the
know.
next one, you move it to 1 to the right.
So
So
it's 101. 10,
So it's
2.25.
2.25.
Wait, what is?
The second one.
Explain what happens to the,
How do you get minus numbers? How do you make
You-
minus numbers?
You
the
have it's
exponents
two's
written in
complement.
2's. Is it both the exponent and the mantissa
Yeah,
written in
yeah.
Yeah, no, they're both in 2's complement, but if it's 1.0, surely that's negative, right?
Yeah, it is.
Yeah.
And you move it 1 to the right.
Do you want
I
me
think-
to get up the
So
negative?
isn't that minus 3 plus a half? Or a quarter? Or minus 2 plus a quarter?
Let me get up a question.
Oh,
Get a marks in for this.
Oh no, we know the answers.
What is it?
Oh, wait a second.
Is it 2 1/4 or minus 2 1/4? No, it's minus 2 plus a quarter.
Yeah, minus 2 plus a quarter, yes, it
It's,
is.
it's minus 1.75.
Because remember, it's 2's complement.
even in the binary form, like not the mantissa or the exponent.
Yeah, no. Otherwise, you wouldn't be able to get minus numbers.
Yeah.
It's Alex. Can you get the mark scheme?
Yeah, I am. I'm pretty sure.
Ah, okay, so it
Because
is.
it's,
Good thinking, Daddy.
because think about it. When you have 0.11, it's
Yeah,
half
it was
plus a
minus
quarter.
1 3/4.
I was right.
Damn you, Nimrod.
Okay, I'm probably gonna go to sleep soon.
Oh, does Nimrod need his beauty sleep?
Yes, because if I go to sleep soon, I'll end up going to sleep at like 11:30.
Yeah.
For a 2-hour exam, you need that energy, bro.
Yeah.
Oh god, it's 2 hours. Don't remind me. That's gonna be so
You
boring.
think I'll get rest breaks if I say my hand hurts when I write? You know, after writing lots of words, my hand starts to hurt. It's probably something medical.
My fingers start to hurt when I type for a long time.
I need rest breaks.
Let me pause this stream. Let me end it. Goodbye, guys.